Hey, welcome back. We are going to solve linear systems algebraically, and we're going to start off by using substitution. So we can solve a system of linear equations through substitution in three simple steps. First, we would solve for one of the variables. We're going to substitute the resulting equation into the other equation. And then once you solve for one of the variables there, x or y, you take that number and substitute it into either equation. You can pause this and jot that down. Meanwhile, I'm going to move on to the first example. So let's see. We're going to solve this system using the substitution method, and you'll notice that both equations are in standard form, and I need to make a decision if I'm going to substitute. I need to solve for a variable, either x or y, and it doesn't matter which variable I choose and from which equation. However, if you want to make your life a little bit easier, I know it's could be challenging at times, so we want to make it a little bit easier. We want to see if we can solve for a variable that has a coefficient of 1, if at all possible. Second best choice is -1. So if we look at the second equation, we see that we have y, which has a coefficient of 1. So I'm going to solve for the y in the second equation. It's going to be a lot easier to do that than any of the other equations. So I'm just going to add 2x to both sides. That's going to leave me with y equals 2x plus 4. Now that I have that, all I want to do is simply take the value here that y is solve for, y equals, and substitute it into the y in the other equation. So what that's going to look like is 3x plus 2, but instead of y now we're substituting this expression of 2x plus 4 equals 1. Now, all I want to do is distribute that 2, and we're just going to start doing our thing as far as solving for x. So we got 3x plus 4x plus 8 equals 1, or 7x plus 8 equals 1. We're going to subtract 8 from both sides, so 7x is equal to -7. I'm going to divide by 7, and check it out, x equals -1. It's pretty nice. Now I'm going to take that x equals -1 and I'm going to substitute it into either equation. Probably the second one's going to be a little bit easier since we have that coefficient of 1 in the y. So for that, I'm going to say -2x. Oh, wait, getting ahead of myself. I'm substituting x, or -1 for x. So, like that. So 2 plus y equals 4. Subtract the 2, and y is equal to 2. So your final solution in this case is actually an ordered pair where the lines intersect. So our answer is -1, +2. I box that in, and we call it sweet. Okay, now we're going to do elimination, a second method, and that's simply going to be you're going to multiply one or both equations to get the coefficients on one of the variables to be the same but opposite signs. So one would be like a +4, the other would be like a -4. Then you're going to add the two equations together. That's going to cancel out one of those variables, leaving you with whatever variable you haven't canceled out left over. Solve for the remaining variable, then substitute like we did the last one. Again, you might want to jot those steps down. I'm going to move on. Okay, so we're going to solve the system using this elimination method. Now I need to decide what I want to cancel out. Okay, do I want to cancel out the x or the y? And it doesn't matter, again, which one you want to cancel out, either x or y. For the purposes of this example, I think I'm going to cancel out the y. Now, x will be easier to cancel out, but I'm just going to make it hard on myself, just so you can see everything that's involved with that. All right, so I'm going to cancel out the y. So I have a 2 and a 3. I'm going to think of, okay, well, what is the least common multiple, the LCM, between 2 and 3? Well, that's going to be 6. 6 is the smallest multiple 2 and 3 both go into. So I'm going to ask myself, well, what do I want to multiply with 2 to get 6? Well, I'm going to multiply by 3. And of course, number one rule in algebra, what you do to one side, you do to the other. That means, in the other one, I want to multiply both sides by 2. However, I want one to be positive and one to be negative. So I'm going to multiply, easy for me to say, multiply both sides by negative 2, because I want one to be a positive 6 and one to be a negative 6, like so. All right, now I'm going to have 24x plus 6y is equal to 12 for my first equation after I multiply the 3's out. When I do the negative 2, I'm going to have 4x minus 6, see there's that opposite sign, equals negative 26. Sweet. Okay. That's the bell! Oh my gosh! We gotta let out now. No, we don't, because we're not in school right now, I don't think. Yeah. So I'm going to add these together. So I will be left with 28x. Now, those 6's, they will cancel out. That's going to get rid of, that's going to give our y's. The 6 y's both gone. That's exactly what we wanted. We want to eliminate them, terminate them. Say hasta la vista. Okay. Now, that was terrible. I apologize for that. Okay, so I'm going to have 12 minus 26, or plus negative 26. That's going to leave me with 14, negative 14. And I'm going to divide by 28 to yield my x. So I'll have x is equal to negative 1/2. Okay? Now that I have my x, I'm going to treat this like that first example and substitute it into one of the equations and find y. It doesn't matter which one. Let's do the, I don't know, let's do the first equation. Okay. We'll say x, or 8 rather, and I'm substituting negative 1/2 into there, plus 2y is equal to 4. That's going to leave me with negative 4 plus 2y is equal to 4. I'm going to add 4, like so. 2y is equal to 8, or ocho, if you're taking Spanish. French, I have no clue, so don't ask. And 8 divided by 2 is 4. So y is equal to 4. We put it together. These two lines intersect at negative 1/2 and 4. Thus, that is our solution to the entire system. This means that this is the only point that's on both lines. Okay? Think of it this way. I'll think of it in the graphical sense that you have points on a line. Any point on that line is a solution to that line because you plug it into the equation and it creates a true statement. Well, this is the only point that's going to be on both lines. That's going to be true for both. If you plug it into both, you'll get a true statement. Okay, moving on. Now we're going to solve this system using any method that we want, any method. So let's see. Well, it's in standard form, so the x's and y's are nicely lined up for us. And I don't have any coefficients of 1, so I think since I'm given a choice here, I'll probably use elimination. And I can choose to eliminate x or y. It doesn't matter. Let's go with, what did we do, y last time? So let's eliminate x this time. Okay, so if I'm going to eliminate x, I'm going to say, all right, well, what's the least common multiple between 2 and 6? Well, 6. 6 smallest is the LCM, least common multiple between the two, because 2 goes into 6 3 times. So I'm going to multiply 3 into both sides, and 6 goes into 6 one time. Oh, but one of them needs to be negative. So since I really don't need to multiply 6 by anything, I can multiply this by -3. Hit two, get 2 birds with 1 stone, I believe the saying is. So I distribute that -3, so -6x plus 9y equals -12. And I bring down that second equation, minus 9y equals 8. And we're going to add these together. Let's see what happens. Well, something interesting happens. Our 6's both eliminate. They're gone. Kaputs. And the 9's, they're eliminated as well. So this eliminates, so that means there's nothing left. We represent nothing with a big fat 0. So 0 is equal to, and then -12 and 8 leaves us with -4. No more variables. So what does this mean? Well, I need to look at what I'm left with. It says 0 is equal to -4. Well, that is clearly not true. 0 is not equal to -4. So because we're left with a false statement, that means there is no solution. When our variables are gone, and we're left with a false statement, we have no solution. So what does this look like on a graph? Well, that's going to be our parallel lines, because there is no point in common between those two lines. So that's what it would look like algebraically. Let's look at it, another one here. We're going to solve this system using any method that we want. It doesn't specify. Let's go ahead and I like how we have a 1x here, so I'm going to use substitution for this. I think that will be the smart route. So if I'm going to use substitution, I'm going to have x minus y is equal to 4, and I'm going to add y to both sides, here and here. So x is equal to y plus 4. Now that I have that, I'm going to substitute this into the second equation for x. So I will have, I'll do it over here, -6, and in place of x, I'm going to have y plus 4, like so, plus 6y equals -24. I'm going to distribute the -6, so -6y minus 24, if you want to sing it, equals -24. Alright, now I start simplifying. Well, I combine like terms. -6y and y gives me, well, 0y. They cancel each other out. It's gone. What? What, you say? Well, I'm left with -24 is equal to -24. Our variables have once again taken each other out. Okay? That's a assurance of mutual destruction. You learned that in world history. Cold War era stuff. Anyway, but this isn't that. This is algebra. Now, since the variables have taken themselves out and we're left with a true statement, that means we are going to have, well, infinite number of solutions. Infinite solutions. Okay? Another way to write that is identity. Because there's two ways to look at it. You can view it as, well, it's one line on top of the other. So they're touching an infinite number of points, so infinite solutions. But one line on top of the other is the same line. It is itself. It is its identity. So that's another way of looking at that. Anywho, there you have it. Solving linear systems algebraically. I hope you got a little something out of it. I know I did. Ciao.